Okay, let's dive into something that becomes pretty top of mind for anyone using a cloud data platform like Snowflake.
Managing the costs, right.
Exactly. Keeping those costs under control. It's incredibly powerful, super flexible, but that consumption model, well, it means you're paying for what you use.
So sometimes that can get away from you quickly.
Yeah, nobody wants that tap on the shoulder from the CFO asking about you know, the data bill.
Absolutely not. It's kind of the flip side of that amazing scalability, that pay-as-you-go benefit.
Right. And we've pulled together quite a stack of sources for this deep dive. We've got Snowflake's own docs, some customer stories, expert articles, all focused on this exact challenge.
Mm-hmm.
Our goal today is really to cut through the noise, pull out the most valuable nuggets, and give you a clear, actionable understanding.
Yeah, like how Snowflake costs actually work, where they tend to hide, and what are the proven ways to manage them effectively.
Exactly. And the point isn't just to be cheap, is it? Or like nickel and dime every credit.
No, definitely not. Because if you cut costs too blindly, you can actually cause reliability problems or performance issues.
Which ends up costing you more in the long run.
Precisely. It's about finding that sweet spot,
Yeah.
optimizing the spend without going, like, too crazy about it.
Still getting the full performance, the full value Snowflake offers.
Exactly.
So by the end of this deep dive, you should hopefully walk away with a solid framework, some concrete tips,
Feel more confident making those informed decisions about your own Snowflake environment.
and hopefully avoid that unnecessary spend. So let's jump in. Where should we start? Understanding the core problem.
Yeah, let's break down what actually makes up that Snowflake bill.
Hmm.
At its core, it's consumption-based pricing. Simple concept. Pay for what you use.
Okay. And the main categories, sort of simplifying a bit based on the sources.
You've got compute, storage, and data transfer. Those are the big three.
Okay, compute, that's primarily the virtual warehouses,
Yeah.
right, where the queries actually run.
Mostly, yeah. But it also includes serverless features, things like Snowpipe, automatic clustering, the search optimization service, even materialized view maintenance.
Okay. And there are cloud services too. What falls under that?
That handles stuff like authentication, managing metadata, compiling your queries, the background orchestration, basically.
Oh, that's storage. That seems straightforward.
It mostly is. It's the cost for the data you store in tables. And crucially, that includes the data needed for time travel and failsafe.
Right, those safety nets. And data transfer.
That's specifically for moving data out of Snowflake, especially if you're going across regions or even to different cloud platforms. That can get pricey.
Okay. So compute, storage, data transfer. Now you mentioned storage is fairly predictable, like per terabyte per month.
Yeah, it's generally less of a focus for day-to-day optimization. Not zero focus, but compared to compute.
Compared to compute, right.
Yeah.
Because the sources consistently point to those virtual warehouses as being the lion's share. Often like 80%, even 90% of the total bill.
That's very common, yes. Those serverless compute and those cross-region data transfers can definitely add up too, so you can't ignore them.
So what really drives that compute cost then, when you look at how people actually use Snowflake?
It really boils down to a few things. The volume of data you're processing, which obviously ties into your queries and how big your tables are.
Yeah.
The efficiency of the SQL you're running is huge. And critically, how appropriately you've sized and configured those warehouses.
It's interesting, Snowflake's own perspective, according to their docs, is that they want you to optimize.
Yeah, they do. Wasteful spending isn't good for anyone. They'd rather you use those credits effectively on high-value projects.
Makes sense. Keeps the platform sticky long-term if you're getting good value.
Exactly. And that brings us back to finding that right-sized approach to optimization. It's key.
Because too little effort.
And boom, you hit that CFO gaze moment we talked about.
But if you cut corners too hard,
You risk reliability issues, poor performance, things that ultimately cost you more in lost productivity or just fixing the mess than the infrastructure savings.
it's a real balancing act.
Mhm.
And the sources seem to agree on a useful framework for tackling this. Visibility, control, and optimization.
Yeah, that's a good way to structure it. Let's start with visibility.
Okay, visibility. Knowing where the costs are coming from.
Exactly. Being able to drill down, explore the details, attribute costs to specific teams or projects.
And monitoring how costs are building up, so no surprises.
Right. And getting that visibility starts with the basics we just covered, understanding the cost components.
But how do you actually explore those costs in practice? Snowsight has those built-in dashboards, which are pretty good for an overview.
They are. But for the deep dive, the sources really emphasize querying the organization usage and account usage schemas.
The usage schemas.
Right. That's where the incredibly detailed data lives. Credit consumption, warehouse usage patterns, query performance metrics. It's all in there.
And I bet querying those directly often uncovers some surprising things.
Oh, absolutely. Not just how much you're spending, but the specific patterns, or sometimes like individual culprits driving up the cost.
Like one bad query running hundreds of times.
Exactly that. Or a warehouse just left running when it shouldn't be. You see it all the time when you look.
And making sense of that often requires attribution, doesn't it? Using tags.
Yes. Object tags, query tags, assigning spending to different teams, projects, data products. It's crucial.
And it's not just for chargeback, right?
Yeah.
The sources suggested tagging is maybe the single best way to find friction points.
Yeah, or like unexpected dependencies driving cost. When Team A's tag suddenly shows up burning credits on a warehouse supposedly owned by Team B.
That's a conversation starter.
Definitely. There's also a newer feature mentioned in the May 2025 sources, cost anomalies detection.
Oh, interesting. What's that?
It's Snowflake using algorithms to look at your past usage trends and automatically flag any weird spikes in consumption.
Ah, so it spots things that just look off.
Yeah.
Based on your history.
Exactly. At the account or even the whole organization level, like an automated watchdog for unusual spending.
Okay, cool. So once you have that visibility, you know what's happening. The next step is control.
Right. Putting mechanisms in place to manage spend, prevent things getting out of hand.
Snowflake has budgets for that, right? Setting cost ceilings.
Yep. Budgets let you control costs for warehouses and serverless features over a set time period.
But a really powerful control, especially for warehouses, seems to be the resource monitor.
Oh, resource monitors are critical. Absolutely fundamental.
Tell us more about those. They track warehouse credit use.
In near real time, yeah.
Yeah.
And they let you set limits to prevent unexpected overspending. You can set them at the account level for total spend or target individual warehouses.
And you define a credit quota.
Right.
Like X credits per month.
Exactly. Say, 1,000 credits for the month on warehouse Y. Then you set notification threshold.
Like alert me at 50%, 80%, 100% of the quarter.
Mm-hmm. And importantly, you define actions when those thresholds get hit.
What kind of actions?
Well, notify just sends an alert. Pretty simple. Suspend and notify is smarter. It lets currently running queries finish, then suspends the warehouse.
Okay, so it doesn't kill work in progress.
Right. But then there's suspend immediately, which does cancel running queries and suspends the warehouse right away. For emergencies, basically.
Wow. These sound non-negotiable.
They really should be. One source shared this truly alarming example. A misconfigured X4 large Hail warehouse.
Uh-oh.
It had auto suspend 0 and min cluster count 10, meaning it was just running full tilt constantly.
Oh, no, how bad was it?
It was billing roughly $89,000 per day.
$89,000 a day.
Yeah. Before they caught it and stopped it, it had already racked up over $120,000.
Okay, that story alone makes the case. Resource monitor on every single warehouse. Period.
Absolutely. Fundamental safeguard. Easy to set up in the UI or with SQL.
Now, beyond monitoring credits over time, there's another key control. Statement timeout.
Yes. Statement timeout in seconds. Your defense against the rogue query.
That single query that goes off the rails, like a bad join or something that just spins.
Exactly. It sits there on a big warehouse just churning through credits. One anecdote mentioned a $12,000 bill.
12 grand from one query over a weekend.
Yep. Because there was no timeout set. Ouch.
So the strategy is put a sensible timeout on every warehouse.
Pretty much. Adjust it based on the warehouse size and what you consider acceptable risk. You know, what's the max cost you tolerate for one query?
Makes sense. A long query on an X6All RGA is a very different cost proposition than on an XL small.
Totally different.
Okay. So visibility lets us see what's happening. Control sets guardrails, prevents disasters. That brings us to optimization.
Right. The third part of the framework, applying strategies to actually reduce cost based on those insights.
And the sources suggest framing this around the main cost drivers: warehouses, queries, and tables.
Yeah, the 3 pillars of optimization, you could say. Let's start with pillar 1, warehouse optimization.
The most obvious thing here is sizing, right? X small up to X6 all large.
Yep. Bigger warehouses generally run queries faster, but they consume more credits per hour. Simple trade-off.
But here's that counterintuitive bit from the sources.
Oh, yeah. The surprising math. Because Snowflake bills per second and warehouses can auto-suspend.
Running a query faster on a larger warehouse can sometimes cost the same or even less.
Exactly. They had this benchmark example. A query took 4 hours on XMall.
Okay.
then 2 hours on small.
Right. And 1 hour on medium.
And the cost.
The cost was the same for all 3 runs.
Wow, so the medium was 400% faster than the X small for the exact same price.
Blew my mind a bit when I first saw that breakdown. It really shifts how you think about sizing.
So the strategy isn't just smaller is cheaper.
No, it's right size for the workload. You need to experiment, increase the size, see if the query time drops significantly.
Keep increasing until the time savings aren't worth the extra hourly cost. Like maybe when the time reduction is less than 50% compared to the last size jump.
That's a good rule of thumb mentioned, yeah. Okay, now what about maximizing throughput, especially for things like batch jobs?
Good point. That's where multi-cluster warehouses come into play.
Instead of queries just lining up waiting for one warehouse?
Multi-cluster lets Snowflake automatically scale out. Add more compute nodes to run queries in parallel.
So the whole batch finishes faster.
Much faster, usually. And since you're only billed for the compute actually used, and it scales back down and suspends when done, it's often more cost-effective than serial execution.
What are the key settings there?
Yep.
Min cluster count and max cluster count.
Yep. Min is the base size, max is how far it can scale out, and the scaling policy matters too.
Economy versus standard.
Right. Economy is generally better for batch. It waits for a bit of a queue to build up before scaling, maximizing utilization.
Whereas standard scales out more aggressively to minimize wait times for interactive users.
Exactly. So seeing a short queue on a batch warehouse using economy, that can actually be a good sign. It means the warehouse is busy, fully utilized, as long as the jobs are finishing on time.
Got it. And any general warehouse best practices that popped up?
A few recurring ones. Group similar workloads onto dedicated warehouses. Tailor configurations, but be super careful with things like turning off auto-suspend.
Use data SLAs maybe to understand and justify the compute needed for critical stuff.
Yeah, that's smart. Start small, then right size based on actual usage data. And seriously, I'll say it again, always set a resource monitor.
Okay, message received on resource monitors. Moving to pillar 2, query optimization.
Right. Key insight here. Cost isn't really about the number of queries you run. It's about their runtime and the resources they consume.
Data scan, complexity, that sort of thing.
Exactly. So the goal is just make those queries run efficiently.
And this isn't only about being a SQL tuning wizard, although I guess that helps.
It does help. But a big part is just using tools to identify which queries are the biggest problems in the first place.
How do you do that?
Well, consistent use of query tags is a big one. Helps you see expensive queries by team or application. You can run native Snowflake queries against those usage schemas we mentioned to find, say, the top 10 most expensive queries in the last month.
Right, use the data Snowflake provides.
And data observability tools were mentioned too, like Monte Carlo in one source. They can surface insights like deteriorating queries, one's getting slower over time.
Oh, that's useful. Or heavy queries.
Yeah, the top 5 by runtime or bytes scanned. They gave this crazy example. One heavy query ran 156 times in a week. Total runtime, 15 hours.
15 hours for one query, repeated. That is definitely low-hanging fruit for optimization.
You bet. And that ties right back to the statement timeout we discussed under control.
Ah, right. Once you identify those heavy or runaway queries.
Having that timeout set prevents them from causing financial damage while you figure out how to optimize the SQL itself. It's a safety net.
Okay. Pillar 3, table optimization. How does table design impact cost?
Simple connection, really. Querying massive tables, especially inefficiently, just takes more compute power and runs longer. Directly hits the bill.
So what's a simple win here? Something often overlooked.
Deprecating unused tables. Seriously. Engineers sometimes hoard data, just in case, or because they're not sure who uses it.
But those unused tables aren't free.
Nope. They incur storage costs, potentially some serverless maintenance costs, depending on features used, and they just clutter things up, making it harder for users to find what they do need.
Okay, clean up the clutter. What about optimizing queries on the large tables you actually do need? Snowflake has features for that, right?
It does. Table clustering is one, good for very large tables, maybe 3 terabytes plus, that don't change constantly but get queried often with filters or sorts on specific columns.
It physically rearranges the data.
Co-locates similar rows based on a cluster key, yeah. Makes scanning much faster, but caution. Don't overcluster. It's not cost-effective for every single table.
What else? Search optimization service.
Right, that's a serverless feature. Great for speeding up point lookups, like finding all transactions for one specific user ID on massive tables, billions of rows.
Best for queries that take a while now, maybe over 10 seconds, and return a decent number of rows.
Yeah, like 100K, 200K values, that kind of range. It adds an optimized search path specifically for those lookups.
And materialized views.
Available in Enterprise Edition. These pre-compute results for common, complex queries, especially ones that hit subsets of large tables.
So use them when the underlying data subset doesn't change too often, but the results are needed frequently, and the query itself is expensive to run.
That's the sweet spot for MVs, exactly.
Now, how do you find those unused tables we talked about? Or figure out which tables are driving query costs?
Data observability or lineage tools can help a lot here. One source mentioned Monte Carlo insights, showing things like asset popularity, query counts, user counts.
Last used dates, read-write activity.
Yeah, all that context to help flag candidates for cleanup or optimization. There was a quote from ShopRunner about just seeing who actually uses the data.
Yeah.
It frees up processing time from stuff nobody needs anymore.
Makes sense. And you can query Snowflake's own access history schema too, right?
You absolutely can. Gives you direct usage info. And one final simple table tip. Use transient tables.
For temporary data, one-off analysis.
Exactly. Unlike permanent tables, they skip the fail-safe storage costs, which can quietly add up over time if you use permanent tables for everything temporary.
Good tip. So, pulling it all together, looking across the sources, what are the most common ways people end up with a surprisingly high Snowflake bills?
It often comes down to a few classic mistakes. Over-provisioning warehouses is a big one, not right-sizing them, either too small or too large and left running.
Ignoring basic architecture or best practices? Sloppy data modeling, bad table design?
Yep. Just letting unused database objects linger, tables, views, whatever, accumulating cruft.
Using some of those serverless compute features without really understanding how they consume credits.
That's another one. Or unnecessarily transferring data across regions or clouds.
Right, you mentioned Snowflake EKO can help with cross-region sharing without egress fees, but if you're manually replicating large data sets across regions.
That can definitely incur significant costs. Watch out for those egress fees.
Okay, so summing up the tools available, you got Snowflake's native stuff.
Right. The usage schemas, Snowsite dashboards, the new cost anomalies feature for visibility.
Legits, resource monitors, statement timeout, tags for control.
And then features like clustering, search optimization, materialized views, plus query history analysis for optimization insights.
It's a pretty good native toolkit, but are there limitations?
Well, sometimes fully leveraging those native tools, especially the deep dives into usage schemas, might require elevated permissions.
Which might not fit a self-service model.
Exactly. Or it just involves a lot of manual querying and analysis, which adds overhead for data teams.
And that's where external tools sometimes come in.
That's the idea. Using a platform, like Atlan was the example in one source, that connects to Snowflake's metadata, including those usage schemas.
To provide additional insights. Or automate things.
Both, potentially. They can build lineage graphs, visualize data flow, make it much easier to spot unused or duplicate assets.
Pull in those popularity metrics we talked about, query counts, last used dates to flag cleanup candidates.
Right, and help manage the governance workflow around actually deprecating things safely.
So the key value is adding context.
Yeah, layering that metadata context, ownership, usage, dependencies onto the raw cost data. It helps you make smarter decisions and fosters accountability across different teams.
A unified metadata view can really boost those cost reduction efforts.
Definitely.
And to show this stuff actually works, there was that AT&T case study.
Oh yeah, great example. They moved from complex on-prem systems to Snowflake. Huge improvements in performance, data access.
Same cost.
Big time. They estimated 84% savings on annual costs compared to projections, partly from things like better query performance and result caching.
84% is massive.
It is. And they got sub-second response times for 90% of their self-service dashboard queries. Really enabled data democratization.
But the really interesting part for this discussion
Was that after those initial migration savings, they went back and did more optimization work.
and shaved another 35% off their Snowflake bill.
Another 35%, on top of the initial huge savings. And they directly correlated this with improving their time to market for new data features, weeks or months down to just days.
Wow. So it really proves that investing time in understanding and actively managing Snowflake costs pays off. It's not just saving pennies.
Not at all. It drives efficiency, enables faster innovation, helps you get the absolute maximum value from the platform.
Okay, so wrapping up this deep dive, managing Snowflake costs. It's clearly an ongoing process, isn't it?
Absolutely. Constant vigilance, understanding where the spend is going, and strategically applying these optimizations. Warehouses, queries,
It's
tables.
not about being cheap, but about being smart,
Okay.
efficient, making sure those resources are right-sized for the value they deliver.
Precisely.
So, key takeaways. Revisit warehouse configurations often, especially for batch jobs. Look at multi-clustering. Get serious about finding and tuning your most expensive queries.
And be ruthless, in a good way, about table management. Clean up unused stuff. Use the native features like clustering or search optimization smartly on the big important tables.
And make sure you're actually using the tools available. Query the usage schemas. Set up resource monitors everywhere.
Maybe evaluate external tools if they can help surface insights or automate processes using that valuable metadata context.
Right. And here's maybe a final thought to leave everyone with, something pulled from one of the sources.
Okay.
It's suggested that roughly 70% of Snowflake compute costs often come from automated jobs. Things like ETL, ELT transformations, data pipelines.
70% from automated jobs. Wow.
Yeah. So the question for you, the listener, is as you look at your own Snowflake bill and think about optimization, where are you focusing most of your effort right now?
Are you spending time trying to shave a few dollars off interactive dashboards?
Or are you targeting those automated jobs that might be driving the vast majority of your actual spend?
That's a really good question to ponder as you work towards a truly cost-optimized Snowflake environment.
Indeed. Well, thanks for joining us for this deep dive into Snowflake cost management.
My pleasure. Lots to think about.